On today's episode, U.S. Steel bets $3 billion on America, and Goodyear's low-carbon tire project makes progress. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. Most people don't think much about tires. They're round, black, and support just about every form of transportation, from passenger cars and freight-carrying trucks to airplanes. What isn't readily apparent, however, is that pneumatic tires are a very high-technology product, and both the raw materials that go into tires and the processes used to manufacture them are carbon-intensive. In 2020, the Akron, Ohio-based Goodyear Tire Rubber Co. set an ambitious goal: create a prototype tire made from 100% sustainable materials in 10 years. Now, 2 years in, the company has made progress and has unveiled a test tire with 70% sustainable material content. While natural latex and synthetic rubber forms the bulk of a tire's composition by mass, tires are in fact composite structures with fabric or metal belts and metallic wire bead reinforcements. Rubber compounds are different in the inner liner, sidewall, and tread construction, and the additives used in each determines much of a tire's performance, from grip, wear, UV resistance, flexibility, and rolling resistance, among others. Some additives, such as tackifiers, are process aids that help keep the green tire together before it enters the mold. The sustainable prototype uses 13 novel ingredients in 9 different critical tire components. Silica, a commonly used additive that enhances grip, is derived from rice husk ash, a byproduct of rice processing that is commonly discarded in landfills. Epoxidized soybean oil has been widely used as a plasticizer in PVC plastics, and Goodyear makes use of soybean oil to reduce the use of petroleum-based plasticizers. According to the company, the production of soy protein for food and animal feed results in significant soybean oil surpluses, making the product practical for tire manufacturing. Tire belts have been made from natural fibers, synthetic fibers such as nylon and polyester, as well as steel. The sustainable tire uses resin recycled from waste plastics, reformed into high-strength technical-grade polyester. From both the CO2 and a structural perspective, however, carbon black is the critical ingredient. Carbon black not only gives tires their characteristic color, it adds strength to rubber compounds and made pneumatic tires a practical proposition for the automotive industry over a century ago. No compound has yet matched it for performance and cost. Now, carbon black has traditionally been produced by combustion of petroleum products, but the prototype tire uses 3 different carbon blacks derived from methane, plant-based oils, and from carbon dioxide itself. Carbon black made from combustion of biological materials reduces net CO2 emissions, and if the product can be derived from CO2 directly, it could even be carbon negative. Goodyear states that the test tire performs well, and the tire business is extremely competitive. The green credentials of tires made today focus on low rolling resistance to reduce vehicle fuel consumption. Will future consumers opt for tires that are themselves carbon neutral? By 2030, a tire's CO2 footprint may be a selling proposition as important as traction, low noise, and ride comfort. We'll check in as this technology evolves. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. Steelmaking is the cornerstone of all industrial economies, but in the last 30 years, the industry has evolved into multiple segments serving unique markets. In overall tonnage, Asia leads the world, particularly China, but the American steel industry, in fact, has moved up the value chain, making more sophisticated alloy products and semi-finished goods, particularly sheet and strip for the consumer goods and automotive industries. Now, the key to cost-effective production for those markets has been the development of the mini-mill. Mini-mills use electric arc furnaces to melt scrap as the primary input, then add alloying compounds in precise amounts to produce steels with highly tailored properties. U.S. Steel has just announced a very large $3 billion investment in Osceola, Arkansas, close to the company's recently acquired Big River steel plant. The new facility will use 2 electric arc furnaces with a 3 million ton per year steelmaking capability, and notably will launch the first U.S. operation of an endless casting and rolling line. This technology is key to cost-effective production. Conventional processes involve the casting of steel into ingots or billets, which are subsequently reheated and passed to rolling mills for forming into useful shapes. Continuous casting, as the name implies, allows single-step production by turning steel castings 90 degrees into horizontal strands, which can then be rolled immediately. It's possible to make finished steel shapes in 1/10 the time of previous batch processes. Continuous casting isn't itself new, and U.S. Steel itself used the process in the 1960s, but the combination of the process with the flexibility of the electric arc furnace allows the company to achieve the high throughput rates of commodity steel production with higher value specialty steels, including electrical grades for fast growth applications such as electric motor production. Primary steel making from iron ore will never go away, but the new Arkansas facility suggests that the future of U.S. steel making may be to selectively take market share in the high-value product categories, then work down the value chain toward commodity steels as automation improves. Well, that's it for today's episode of This Week in Engineering, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.